Why hello geometry students, this is lesson 53. Apparently I can't even talk today. The objective for today is what are the properties of a 45, 45, 90 triangle. And this is one of what we call a special right triangle, and there's another one we'll talk about later. But this one comes about because a lot of times we use squares, and whenever you take a square and cut it diagonally from corner to corner, remember every square has right angles, and we've just recently talked about properties of rhombuses. Remember the diagonals bisect the angles, so that means this angle is the same as this one, and the same as this one and this one. So that means these angles are 45 degrees. This one, of course, is a right angle. So this is a pretty common triangle that shows up a lot, and so we have put forth some effort into studying these. So let's find this length of the hypotenuse, so I'll call it h, by using Pythagorean theorem. So I know x squared plus x squared is going to equal to h squared. X squared plus x squared is 2x squared is equal to h squared. Trying to solve for that h, we'll take the square root of both sides. End up with h is equal to the square root of 2 times the square root of x squared. The square root of x squared is just x, so h is equal to, rearranging here, x square roots of 2. So this is x square root of 2. So what that means is if I know either one of the side lengths here, the legs of the right triangle, or if I know the hypotenuse, I can find the other ones. I don't have to know two of them, I have to know one of them and I can find the other ones. So let's practice it now. It says find the missing sides. So I know this one over here is going to be 3 inches because, well, those lengths are the same, right? Because it's a 45, 45. And then this one up here is going to be the side length times the square root of 2. This is going to be 3 square roots of 2. And yes, it really is that simple, at least for this one. On part B, it gets a little bit more complicated because it gives us this, okay? And remember that h, we'll call it, is x square roots of 2, where x is this side length over here, or down here, either one. So what I'll do is I'll plug in that 5 is equal to x square roots of 2, and now I need to solve for x. So I'll divide both sides by the square root of 2. Here that becomes a 1, and I end up with x is equal to 5 over the square root of 2, but we can't have any radical parties in the basement, so we're going to rationalize that. And I end up with x is equal to 5 square roots of 2 over, remember that bottom is going to be the square root of 2 squared, or just 2. So that is what those side lengths are going to equal to there. Part C says find the perimeter of each of those. Let's see here. Let's say this is the perimeter of A. We'll just be adding up all the sides. So it'll be 3 inches plus 3 inches plus 3 square roots of 2 inches, which would be 6 plus 3 square roots of 2 inches. And then the perimeter of B would just be 5 square roots of 2 over 2 plus 5 square roots of 2 over 2 plus 5. These two together would be 10 square roots of 2 over 2, which would just be 5 square roots of 2. 5 square roots of 2 plus 5, and that's centimeters on there. So those are your two answers. Your homework is there on page 351. You do the lesson practice, all the 53s, all the 52s, and then a whopping 2 more of your choice.